Hi everyone, I am Hằng. In this video, I will talk about the first law of thermodynamics. So, let's take a look on this formula. Delta U equal Q plus W. I explain each of them, okay? U is the internal energy of the system. And when I write here delta U, that means I get the final internal energy minus the initial internal energy. So I have the change of internal energy of the system. What is the internal energy? You take a look on the lecture 4, talk about the ideal gas. So over there you have a definition about the internal energy. Next, Q here is the heat that the system receives, and W here is the work that the system receive. Okay. How many ways to change the internal energy of a system? There are two ways. Take a look here, you see clearly. The first one, perform a heat. The second one, do a work. So how do we do it? The first way, you burn the system. For example, this is the system. You burn it. That means the system will receive the energy from the heat. Receive energy in kind of heat from the heater here. Next, the second way, to perform a work like this, you press the piston down, so that means you perform a work for the system. In this case, the system receives the work from outside. Okay, conclusion in this slide, you should remember this one is the first law of thermodynamics. So what does it mean? You have the change of internal energy, the heat that the system receives, the work that the system receives, and we usually call this one is work done on the system. The next slide, I will introduce how to calculate the work and about the change of internal energy. So we know that we know the formula for internal energy. It depends on temperature. So the change of internal energy is actually the change of temperature. So up to now we know the change of internal energy. And the next slide, I will show you how to calculate the work. And finally, based on this first law, you can calculate the heat. From here, you get the heat out. So the heat will calculate based on the change of internal energy and the work. Now we quickly move to the work. But before moving to the work, we have some conventions here. So remember, when we write Q here, that means it is the heat transferred to the system. That means in this case, the system receives the energy. If the system receives energy, so we usually consider Q here greater than 0. Next, if the system release energy, so in that case, we denote Q with the sign here, Q prime here, and it equal minus Q. Okay, so if it means that if the system release energy as heat, so that heat we denote is negative. Okay, and here if we write W is the work done on the system, that means someone or something outside the system performs the work, and the system receives that work. So we denote W the same as the heat. So here, if we write W prime here, that means it's equal minus the W. And remember, if the work done on the system, that means the system receives the work. So therefore, the work here greater than 0. And in the opposite direction, if the system has to work, so that work we will denote as W prime here, and it's a actually in that case the work will be negative. Okay, The work prime will be negative. There's some mistake here. And here is the formula to calculate the work done on the system. That means something or someone else outside the system perform a work for the system. So we call that one is the work done on the system, okay? In this case, you calculate by this way. The work equal minus, you do the integration from V1 to V2 P dV. So how do you receive this formula? This formula you receive from the formula based on force and distance, okay? So the definition, we denote work done on the system equal minus, remember minus here, you do the integration from V1 to V2 P dV. How to get this? So we base on the force and the distance, okay? From now on, we will focus on 4 processes: the isothermal process, and then what else? Isothermal process, and then what do we have next? Isobaric, that means pressure is constant. Isovolumetric, that means the volume is constant. And adiabatic, so the heat is equal 0. So we go one by one, okay? So here, remember, we have for each process we have to calculate the work, the change of internal energy, and then based on the first law we calculate the heat. Before doing that, I remind a bit about this equation for ideal gas and this formula for internal energy of a system, okay? So now we move to the first process, isothermal process. So how do we calculate the first? We apply the first law for isothermal process. Firstly, let's talk about this process. What does it mean? When you hear thermal, that is something related to temperature. That means if isothermal, that means temperature is a constant. If temperature is a constant, take a look on this equation. If temperature is a constant, that means PV, P times 2V equal constant. P times 2V equal constant. What does it mean? This one we call this one is the equation of this process. What does it mean? It means P1 V1 equal P2 V2. From this equation, usually people give you 3 quantities. For example, P1, V1, P2, and the question will ask you V2. So from this equation, you can get the answer. Next, I will remind one more time, the main purpose here is you try to find the change of internal energy, the work, and the heat. So here, based on this formula, the formula for the internal energy, you see, if you want, N is the number of mole of the air, of the gas in the system. R, capital R here is the constant, and T here is the temperature. So you take a look. If you want to calculate the change of internal energy, you have to calculate the change of temperature. But in this case, temperature is a constant. Therefore, the change of temperature is 0. That means the change of internal energy is 0. So here, the first law, I write 0 here. If I write 0 here, that means the heat equal minus the work. Next, now if I want to calculate the heat, firstly, I have to calculate the work. Okay, so how do we calculate the work? This one is the formula for the work. In this case, because P is not a constant, so I cannot move it out from the sign of integration. Actually, I calculate the P depends on V by this equation for ideal gas. So from here, I have a P equal nRT over V, where nR is a constant. Okay, so I have this formula. If T is a constant, so nRT, all of them are constant, so I move it out from the sign of integration. So inside the integration, I just have a dv over v. So when you do the integration, you have the natural log of v, and then you put v2 minus, and then you put natural log of v1, and you remember that if you have a natural of v2 minus natural of v1, so you can write in form of fraction like this, natural log v2 over v1 like this, and on nRT is constant, so you write it here, minus, because of the formula you have a minus, so you always repeat the minus. So here is the formula for the work. And now how do we calculate the heat? You just add one more minus before the work. That means here you add one more minus. Minus with minus, you have plus. So the heat will be plus. So conclusion. In this slide, you should remember three things. The first one is the equation of isothermal process. The second one is the work. When you remember the work, so the heat equal minus the work. And remember the work is like this. And the change of internal energy, of course, 0, because the temperature is a constant. Thank you for listening. The next video, I will continue with this, the first law of thermodynamics. I will talk about the lab processes in thermodynamics. Thank you for listening.